Gotta keep the content stream going so you don't lose viewers. Yeah, you don't have my screen. I got your screen. Now do you have my screen? Anybody else not have my screen? That wants it? Okay. Wait, what? You want it? Okay. You can have it, Nikki. How's that? Like a dream. Okay, dokie. So, we left off down here where it says coding exercise, close to the bottom. It says the student class can also inherit from the class person just like employee and customer because a student is a person. I see it that way. A student is a person. What do you need to add to the student class declaration below to make it inherit from type person? Okay, let's look down here. Right now you have a class person that has a name, and you have a class student. Right now the class student is not inheriting from class person. What do I need to add to make it inherit? I heard it. Extends person. Now the student actually inherits from person. This says a student is a person, which means a student is going to have a name now. How nice. Okay. So that's what we need to add. It says when you, so if you were not following along there, I just added this line. It says extends person. That makes it so that student inherits from person. When you fix the code, the instance of operator will return true. That student S is an instance of both student and the person class. So if you look down below, you see student S equals new student. There is this new operator called instance of, all lowercase letters. It's so interesting that it's not even camel cased. And the way instance of works is you can think of it like a comparison operator for objects and classes. This says, is the student object S an instance of student? And it returns true or false. Well, is a student a student? Yes. So the first one returns true. Now, since we just made it so that student inherits from person, is a student a person? Yes, so they're both true. So if I were to go ahead and run it at this point, it says true and true. If I don't have this extends person part, if I just delete that for a second, S instance of person, I can't even make the student. I disagree highly. Okay, apparently it makes it so I can't compile. That's interesting. I don't know why that is. I wish I knew. Why can't I say interesting? Okay. Anyway, this makes it so that a student is a person, and so that instance of operator I would like to add to my notes. That's what I'm going to do here. Not you, but you. Let's talk about the instance of operator real quick. Where's my red? There you are. What? This should be green? Okay. Instance of, how does it work? Well, great question. Essentially what instance of does is it returns true or false. How does it work? Well, the way that it works is you say some object instance of, oh my gosh, I tried to camel case it. What is this, amateur hour? Some object instance of some class. That's how it works. What is it used for? Well, I don't know. Like if you see that an object is a person, maybe you can use their name now. There's certain things you can do if it's a person. There's certain things you can't do if it's not a person. So maybe you want to do something like, if this object is a student, calculate their GPA. If they're just a person, you're not going to calculate their GPA, right? So it can be used in if statements. Here it's just used for printing. I wanted to add one question for instance of, since our questions are so blank here. Let's do something like this. Let's do like public class shape. Let's set up a little hierarchy. Let's do public class. Let's do rectangle extend shape. Sorry, I should have written smaller. And let's do public class square extends rectangle. Write really small. Okay. Okay. So let's say I then do something like rectangle. No. Lies. Let's say I do square S equals new square. Let's evaluate some things. S, instance of square. Let's start there. What is that going to evaluate true? 2. What is that going to evaluate 2? True. How did you guys know? You're so smart. Teaching is so much easier if I just give you the answer before I ask the question. No administrators, okay. Let's try another one. What about, let's do S, I'm just going to shut my fat mouth here. S instance of, not that there's anything wrong with it being a fat mouth, just saying, rectangle. Get out of here, guy. What's that going to evaluate to? True. A square is a rectangle based on this hierarchy that I have set up. This will evaluate to true. All right, here comes the curveball. What does that evaluate to? Is a square a shape? In the code, is a square a shape? Let's think about this hierarchy. Maybe it'll help if I draw it out for you. Shapes all the way up here. And then we're saying that rectangles are shapes. And then in this hierarchy drawing, we're also saying that squares are rectangles. So is a square object S an instance of a shape? Yes, it falls under that umbrella. This is why I was saying yesterday it's kind of like biology. You're dealing with hierarchies. All right, I got one more for you. Heck yeah, keep them coming. There's one thing missing from my hierarchy, maybe. Thank you, Daniel. Okay, when I say public class shape here, what's really implicitly happening? Well, it's implicitly saying public class shape extends object. So the one part missing from my hierarchy drawing, no matter what, every class you make is always going to be inheriting from object. So this last one here is true as well. In fact, any object you make is an instance of object. A string is an instance of object. A scanner is an instance of object. A square, instance of object. Person, student, they're all instances of object. Anyway, this is how I deal with questions about inheritance. I always look at the class headers. I draw a hierarchy out. I think when I draw a hierarchy like I have here, it helps me figure out what falls under the umbrella. Okay, a shape is an object. A rectangle is a shape, a rectangle is an object. A square is a rectangle, a square is a shape, a square is an object. Does that make sense so far? Do you want me to give you one more brain buster or no? Let's do one more brain buster. Okay, let's say, give me my blue back please, thank you. Let's say I do something like, scroll please, thank you. If I do rectangle R equals new rectangle. What if I say R instance of square? Oh, somebody's getting a message. False. A rectangle is not a square. A square is a rectangle is not a square. Now you guys know that because you've taken geometry and all that stuff. But if I'm using a different example, do we understand why why rectangle R is not a square? Look at the hierarchy. Rectangles do not fall under squares' umbrellas. Okay? It's like some animals might be primates, but not all. Wait, some animals might be primates, but not all animals are primates. Square falls under the rectangle umbrella, but not vice versa. So this returns false. Somebody's going to have to start fact-checking these videos. All right. Questions there about instance of or hierarchies or extending or anything like that? Okay. Well, I know we still haven't seen the utility necessarily, but what we have done is we know how extends works. We know how to set up an inheritance relationship, and we know kind of what an inheritance relationship means. It means two things. When you inherit, you get all instance variables from the parent. What else do you get? All public methods. So those two things you inherit from the parent. We're going to keep looking at that moving forward. What I need you to do next is switch links. Let's go into the future, which is the present, and look at today. I have a link on the right that says 9.1.4, is a versus has a. If you can click on that. There's just a little bit here, trust me. Okay, it says another type of relationship between classes is the has-a relationship or association relationship. We looked at the is-a relationship yesterday. Now we're looking at has-a today. Use this when the object of one class contains a reference to one or more of another class. For example, a course can have many course periods associated with it as shown below. The one near the course means that one course object is associated with the number. Okay, I don't know why they're going so much into UML diagrams. We don't need to go that far into UML diagrams. Basically what it's saying is that a course can be made up of several course periods there. In the code, the course class has an array or an array list of course period objects as an attribute inside of it. So how do you guys want to do this? Do you want to add just on the same side here, or do you want to flip it over and do day 2? Flip it over? Okay, sure, I can do that. Sounds good. So I'm just going to flip it over here. I'm just going to say day 2, inheritance day 2. Today is the 4th. Have they finished counting up the Iowa caucus stuff yet? Anybody know? They're still counting it, okay. Let's see here. Has a relationship. So yesterday we talked about the is a relationship, where that's just inheritance. Like a square is a rectangle. The has a relationship is sometimes called association. It can be called different things. Let's see if we have a good definition here. One class contains a reference to one or more of another class. Let's say that. All right. I don't like their example that much. Can I give you a better example? Good. Here's a has a relationship. If I'm writing a student roster program, the class will have a bunch of students in it. That is a has a relationship. A class has students. Here's another example. If I'm writing a parking garage app or something like that, parking garage program, a parking garage has many cars inside of it. That is a has a relationship. A parking garage has cars. Does that make sense? So I would not say parking garage extends car. I would just have a public class parking garage that maybe has an array of car objects inside of it. That's a has a relationship. So maybe I'll write down that example, something like this. I could say public class parking garage It's not going to extend the car class because a parking garage is not a car. It's not a is a relationship. It's a has a relationship. So then inside of there I might have an instance variable that's like private car array cars. That is a has a relationship. A parking garage has an array of cars inside of it. A parking garage is not a car, it just has cars. Let's use like the human body for an example. If you're writing a program to represent the human body, you could say the class human body has 2 eyes, a head, 2 arms, 2 legs. A human body is not a leg. Okay, do we agree there? All right. Human body is not a leg, but it has legs, it has arms, it has eyes. Its composition is another word that we use when we're talking about has a relationship. So some words you might see when you're thinking about has a relationship, you might see the word association, you might also see the word composition. In other words, a parking garage is composed of cars. The parking garage class is associated with the car class, but it's not a car. That'd be cool, though. It's like that thing in, did we talk about this yesterday? It's like that thing in, that carries the cars that's always in, like, Fast and Furious movies? Okay. That's not what's going on here, though. All right. So that's the has a relationship in a nutshell. Questions on it so far? Do we see how it's different than is a? Okay. All right. Moving on. Alternatively, we could say that a course period has a course attribute inside of it to hold the information about the course. It is up to the programmer how to design these 2 classes depending on which type of association would be more useful in the program. So here, a course period is made up of a course object. That's a has a relationship. Here's another example. Consider the class student and course and an AP course. An AP course is a special type of course. Students are in courses. What are the relationships between these classes? Oh, cool. All right. Is an AP course a course? Yes, an AP course is a course. Is a student a course? No. What's the relationship between course and student? Course has a student. Okay, you guys are getting it. You guys are so smart. Okay. Yeah, there's some code there. I'm going to skip over that code. You can peruse at your own leisure if you want to. There's something called the is-a substitution test. If you aren't sure if a class should inherit from another class, ask yourself if you can substitute the subclass type for the superclass type. For example, if you have a book class and it has a subclass of comic book, does that make sense? Is a comic book a kind of book? Yes, a comic book is a kind of book, so inheritance makes sense. If it doesn't make sense, use association or the has a relationship instead. Again, is a leg a human body? No. Is a parking garage a car? No. Those should be has a relationships instead of is a relationship. It says only use inheritance when the child class is really a type of the parent class, otherwise use association. Now, inheritance is tested many different ways on the AP test. Some of them are very theoretical questions about how you would design a program. Here's an example of one. It says an online store is working on an online ordering system for books and movies. For each type of published material, they need to track the ID, title, date published, and price. Which of the following would be the best design? It says A, create one class published material with the requested attributes. B, create classes book and movie, and each class has the requested attributes. Well, if we do B, aren't we going to be copying the same thing over and over again? I don't think that's good design. C says create the class published material and have book and movie inherit from it all the list attributes. Oh, now this is interesting. Let's use the substitution test. Is a book a published material? Yes. Is a movie a published material? Yes. So I think inheritance might work there. D says create one class bookstore. I don't think we're representing the bookstore. We're all talking about the objects in the bookstore. E says create classes for published material, books, movies, title, price, ID, authors, and date published. That seems like overkill. Like price. Do we need to create a class for price? Couldn't that just be a double? I don't think so. I'm guessing the answer here is C. Is that right? No? Yeah, okay. Okay. Let's look at the next one. It says an online site shows information about books and authors. What kind of relationship do these two classes have? And is a relationship? Is a book an author? No. And an author's not a book. And is a relationship? No. A has a relationship? Yes. A book has an author attribute. So I would say C for that one. It does not pass the is a substitution test. And then the last one, what Java keyword is used to set up an inheritance relationship between a subclass and a superclass? Extends, C. All right. There's a programming challenge that I wanted to do with you. I thought it would be fun. It's down here. It's called Online Store. It says working in pairs or groups. We're a group, everybody. You're in my group with me. It says design an online store with classes for store, item for sale, book, movie, and author. First, do some research in an online store like Amazon to see what information they store on books, movies, and authors and what... Okay. Let's do some of this here. I got to write it down. All right. I'm going to need your help. You guys are going to have to search and help me here. So... we need books, we need classes for store, items for sale, book, movie, and author. So let's just look at books, movie, books and movies? Yeah, books and movies, books and movies. Okay. So we've got a couple different classes. Item for sale. We've got book, movie, author. And we'll talk about the store a little bit later because that's a little bit generalized. All right. Item for sale, book, movie, author. Just looking at Amazon for items for sale. Go on Amazon.com. Let's do this. Oh gosh, am I logged in? Don't look at the weird stuff I've been looking at. Okay. Continue watching Murder, She Wrote. You guys just want to watch Murder, She Wrote? Recently viewed. Yo, so my parents also get on this account sometimes, so that's not me, I promise. Danka. You have to believe me. What is it though? I don't want to know. I don't want to know what mom and dad are planning on doing. Oh gosh, is it for taxidermying the dog? I hope not. Okay. Let's search for something like a book. It's a great book about math. With Steven Strogatz. Get that hardcover. Okay, so... Alright, so I picked a book. What do they have some stuff for a book? It looks like they've got like an author. Let's see here, book. We've got author. We've got, what? Publish date, is that right? What else? Price, rating. Any other attributes? There's like a description, I guess. Anything else you want me to include for a book? Author, published date, price, rating, description. Yeah, Annie? Genre, that's a good one. What'd you say? A report button, report incorrect product information, fake news. Alright, so that's a book. Let's see a movie here. What's a good movie? Daddy's Home 2. Alright, let's see here. Oh God, I can watch it now. Please don't. I'm busy. I can't. Oh, a 6 on IMDb, but the users have spoken. What? I just want... How do I get DVDs? Amazon, I just want to look at DVDs. I am not going to watch Daddy's Home 2 right now. I need one that's not on... Okay, here we go. DVD. You know it's good when it's the Blu-ray's cheaper than the DVD. That's how you know it's good. You can also tell it's good based on the cover being good. All right, for a movie, what attributes do we have? Watch now. No, I'm not going to watch it now. I need attributes. Add to cart. We got price again. We do have rating again. Actors, thank you. Actors. The year it came out, the rating. Oh, I was thinking of rating like, there's like the rating like PG rating. And then there's also like the stars rating, right? I should call this other one stars rating too. 1 star. Type. Oh yeah, type of disc, I guess. Type like DVD, Blu-ray. Okay. Let's see. The author class. Let's go back a step to book. When we were looking at The Joy of X. For the author class, I think there's only 2 attributes for an author. A first name and a last name. Now, I know I can click on Steven Strogatz and look at the other wonderful math books he's written on Amazon, but just looking at it right now, I can't see that information. For example, I click on Nonlinear Dynamics and Chaos with application. Okay, no thank you. Infinite Powers, the story of calculus, the language of the universe. Infinite Powers, how calculus reveals the secrets of the universe.
This one sounds $1,000 for a what?
There's only one left in stock. You better order soon. Sync, The Joy of X. The Calculus of Friendship, what a teacher and student learned about life while corresponding about math.
Are they all about math?
El Placer de la X. Okay. So let's say an author just has a first and last name. Now, what I want to do with you folks is we need to pull out some of these general stuff that book and movie have in common, and we need to combine them. Price, they both have a price. I would agree with you there. You want to do star? Let's pick one more. Star rating, you think? What about, you know what we didn't put on any of these? Title, like what it is. Maybe, so how about we do price and title? Let's pull out price and title here. So title's gone, price is out. We could easily do some of the other ones that they share. Okay. Now, what I've got here is a diagram that I need you to help me connect stuff with. So we're going to say an author has a first name, which is a string, and a last name. We're going to say that an item for sale has a title, which is a string, and then a price, which is a double. Okay? And let's say the book class. What extra stuff does a book have that augments what's in an item for sale? How about we do author and genre? What is the type of author going to be? Yo! Author, thank you, Daniel. And what'd you say, genre? Oh, we could do page numbers too. Okay. What does a movie have that augments an item for sale? Runtime. Okay, we didn't even put runtime on our list. How about rating, like movie rating? String. What else does it have? We did type, actors. Stop. Actors. Okay. Now, what would the type of actors be? How about a string array? Alright, now, the last thing I need you to do with me and help me out here is we need to set up the the is-a relationships and a has-a relationships. What is the relationship between an author and a book? Is it a has-a or is-a? Has-a. So I'm going to do, how do I do the arrow? Help me with the arrow. Ah. Get out of here. All right. What about the relationship between a movie and a book? There is no relationship, right? Except, what about the relationship between a item for sale and a book and a movie? It's inheritance. It is a. Let's fix this here. This is called Creately, by the way. It's kind of interesting. I know. It's so cool. Where's my line? Come here, you. I know, smancy. Give me the right arrow, please. Okay, you're being literally toxic. Let's try this other one. And then the last one, we'll maybe have a little bit more time tomorrow to talk about the relationship here, but what's the relationship between a store and an item for sale? Stores have items for sale. Okay. So we'll say there are items for sale. What is the type of that? Well, the type is item for sale, and maybe an array of items for sale. I don't know, something like that. You don't have any homework, but tomorrow we are going to write this class together here. Can we have a 4D array of items for sale? John, is that possible? We're into it.
Isn't 4D smell?
Smell-o-vision. No. You don't have any homework tonight. There is no